Now we're going to talk about solving absolute value inequalities. These are inequalities because of the greater than and less than signs that are in these problems. And since this is an absolute value, that means these are really going to be compound inequalities, so that we have an either an and or an or situation. The first thing that we want to do, just like the equations, is isolate the absolute value bars. We want to get those by themselves. So for number 16, we're going to subtract 3 from both sides of the equation, give me 7 times the absolute value of negative 8r, close the absolute value bars, is less than 112. Then what we're going to do is again get the absolute value bars by themselves. So we're going to divide both sides by 7. And 112 divided by 7 is 16. The less than sign is going to stay the same since we did not divide by a negative. And that is absolute value of negative 8r is less than 16. Now this is going to get me two equations. The first equation is exactly like this one without changing anything with the absolute value. So negative 8r is less than 16. The second equation is going to be found by taking it and changing the sign of the answer, negative 16. But if we change that sign, it's kind of like dividing by a negative. We have to flip the inequality sign around as well. So these are my two simple inequalities that we can solve and then graph. Divide both sides by a negative 8, and that'll get me r is greater than a negative 2. This is one of the two solutions. You get that because this flipped the sign around because we divided by a negative. We'd take and divide the negative 8 on the other side. Again, we have to flip the sign, so now it is going to be a less than sign, and we'd have r is less than a positive 2. Now the question is this an and or an or graph? And we can tell that from the equation where the absolute value is by itself. We always want to look back to where we got the absolute value by itself. And if we look at the sign, less than, that will tell me what type of equation it is. Less thans are always and, greater thans are always or. So this is an and equation. When we go to graph this, that means we need to care about the overlap. We go to the negative 2, we have an open circle, and we're going to go to the right since it's greater than a negative 2. We go to the positive 2, because it is a less than sign, we're going to go to the left, and then my solution is going to be found where the two arrows overlap, which is in this area right here. So any number will work between negative 2 and positive 2, not including negative 2 and positive 2. On number 17, it is slightly different. As we look at the absolute value, we need to get it by itself. We want to start with this minus 6. Do not combine the 6 and the 7 together. These are not like terms that can be combined because this 7 is really being multiplied by the absolute value. So we can't combine them. Subtract 6 from both sides, and we have 7 times the absolute value of 2b plus 6 is greater than negative 64 minus 6 is negative 70. To get the absolute value by itself, we now need to divide both sides by 7, and those will cancel, leaving me 2b plus 6 is greater than, since we don't switch the sign, a negative 10. These are still in the absolute value bars at this point, and normally we would write out two equations. This will end up being a special situation, which I'll address in just a second after I show you why. 2b plus 6 is greater than a negative 10, or 2b plus 6 is less than, we have to switch the sign, positive 10 when we change the value of the other side. Now I did say or as I was doing this, and I found that by looking at this symbol, a greater than symbol means or. And now we would need to solve both of these absolute value, or both of these individual inequalities separately. Subtract 6, 2b is greater than negative 16, and then divide by 2, we don't change the sign, so b is greater than a negative 8. That is one of the solutions. Or, then on the other case, what we would do is we'd say subtract 6 from both sides, and 2b is less than a negative or a positive 4, therefore b is less than 2. Now, we want to check to make sure that these are going to work. I'm going to go ahead and graph these real fast. b is greater than -8. Here is -8, right about there. It's going to go to the right. And then we have the other one, which is b is less than 2. Open circle, and it's going to go to the left since it's less than. Now, being that this is an OR equation, I need to care about whether my points are on either of the two arrows. And we can see that all the points over on this side are going to be on the blue arrow. All the points over on this side are going to be on the red arrow. And all the points in the middle are going to be on both arrows. And since it's OR, that means that any number is going to work in this case, and we can do that. We can call this all real numbers. And this would be the solution. All real numbers will make both of these equations work. Now, we didn't really have to do all this work. I told you that from here I could have told you what the special case is, because an absolute value will always give you a positive number, and positive numbers are always bigger than negative numbers. That means that this is going to work for all values that we could possibly plug into the inside of the absolute value. So you can stop right here if you notice that this number is negative and absolute values are always bigger than negatives. We could call that all real numbers.